You know when you hit Control F to find a word in some massive document and it just appears instantly? Well, it kind of feels like magic, but it's not. Today we're going to pull back the curtain on the absolutely genius algorithm that powers that find function, and you'll see how it turns what seems like digital wizardry into a really simple, clever process.
I mean, really think about that for a second. You hit Control F, you type in a word, and bam, there it is, highlighted, even if it's in a 1,000-page novel. So how on earth does your computer sift through all of that text so fast without reading every single letter? That is the exact mystery we're solving today.
You see, when it comes to searching for something, there are basically two ways to do it. You've got the slow, obvious way, and then you've got the smart, kind of counterintuitive way. And as we're about to see, the secret to incredible speed isn't about checking every single letter. Nope. It's about starting at the end and learning how to skip ahead. To really appreciate just how brilliant the smart way is, let's first imagine a rookie detective on the case. Their method is thorough, sure, but, well, as you'll see, it is painfully slow.
Okay, here's our case file. We've got the sentence, here is a simple example, and our job is to find the clue, the word example, inside of it. Our rookie detective, well, he gets out his magnifying glass and starts right at the very beginning of the sentence.
So the rookie's method is pretty straightforward. He lines up example with the start of the text and checks letter by letter. Mismatch? Okay, he just shifts the pattern over by one single spot and starts all over again. Is it a match? Great, check the next letter. Oh, mismatch again, back to shifting by one. You can imagine how this would take absolutely forever in a long document.
But now, let's bring in the expert, the seasoned inspector with brilliant, totally revolutionary idea that's going to change the entire game. This right here is where the magic happens.
Our expert's technique is called the Boyer-Moore algorithm, and its strategy is so simple but so powerful. Instead of checking a word from left to right, it checks from right to left. Yeah, you heard that right. By starting at the end of the word, it can use any mismatches not as failures, but as valuable clues to leap way, way ahead in the text.
And that right there is the core genius of this whole method. Everything flows from this one counterintuitive move. By checking the last letter of your pattern first, you gain this incredible advantage when you find a mismatch, because that mismatch tells you exactly how far you can safely jump ahead. So, how does the algorithm know how far to jump? It's not just guessing. It follows two very clever rules, or heuristics, that are basically its secret techniques for cracking the case in record time. The first, and honestly the most powerful technique, is called the bad character rule, and it's all about using the mismatched character in the text as a clue. Okay, so here's how it works. When there's a mismatch, the algorithm looks at the letter in the text that didn't fit, we'll call it the bad character. Then it asks a simple question. Is this bad character anywhere in the word I'm searching for? If the answer is no, it knows the word can't possibly line up there, so it can safely jump the entire length of the word forward. If the letter is in the search word, it just makes a smaller jump to align it perfectly. Either way, it makes a huge informed skip.
The second technique comes into play when we actually get a partial match. It's called the good suffix rule.
So imagine you're searching for the word expression. You've already matched the last four letters, S-I-O-N, which is great, but then the letter before it is wrong. Well, that S-I-O-N part is your good suffix. The algorithm then asks, does S-I-O-N appear anywhere else in my search word expression? In this case, it doesn't. So boom, it can make another big jump. It's just another really clever way to use what you already know to skip way ahead. All right, theory is great, but let's actually watch our expert put these rules into practice and solve a case right before our eyes.
So here's our new case file, a simple text and a simple four-letter pattern we need to find, A, B, C, Z. Let's see how our Boyer-Moore detective tackles this one. Okay, so first, the algorithm aligns the pattern A, B, C, Z with the start of the text. But remember, it doesn't check the A. Nope, it goes straight to the end. It compares the Z and its pattern to the fourth letter in the text, which is an X. And right away, it's a mismatch. And here comes the magic of the bad character rule. The algorithm sees that bad character from the text, the X. It glances at its search pattern, A, B, C, Z. Is X in there? Not at all. That means there is a 0% chance of a match in this position. So instead of shifting by just one, it makes a huge, confident jump, shifting the entire pattern 4 spaces forward.
So after that big jump, it just repeats the process. It checks the last letter again, which now lines up with the Y in the text. Is Y an ABCZ? Nope. So it makes another big jump. And finally, on the third try, everything lines up. The last letter Z matches, so it checks the C, then the B, then the A. It's a perfect match. Case solved, and just a fraction of the time the rookie would have taken.
So just how much faster is this expert method really? Let's look at the final verdict on its efficiency. Now, in technical terms, this is how we measure the algorithm's average speed. But what it really means is something, well, kind of surprising. That fraction tells us that the longer your search pattern is, the faster the search actually goes. I know, it's counterintuitive, but it makes sense, right? A longer word gives the algorithm way more information to make even bigger, more confident skips.
This chart just makes the difference crystal clear. For our simple example, a naive, basic search might have taken 10 or more comparisons to find the word. Our expert method, using Boyer-Moore, solved it in just 3. That's the incredible efficiency you get from intelligent skipping. And you know, this isn't just some clever thought experiment. This is the logic that's working behind the scenes in so many places we use every day. It powers the find function in your text editors. It's used in search engines. And it's even crucial in bioinformatics for finding patterns in these massive DNA sequences. So if you take just one thing away from all this, let it be this. The secret to speed isn't checking harder, it's skipping smarter. This simple, elegant idea, comparing from right to left and using those mismatches to make huge jumps, is what powers one of the fastest and most widely used search algorithms ever designed.
So the next time you hit Control F and you find what you're looking for in the blink of an eye, maybe you'll spare a thought for that invisible detective, working backwards, making those clever little skips, and solving the case for you in a flash.